Hello everyone, welcome back for the fourth video tutorial. In the previous video, I showed you how to do data modeling for our applications as well as database modeling as well using MSDB context. Now the next step is to be able to create a new product here. For example, I can go to the product controller and then I will be able to see the CRUD operation, edit, create, delete, and create a new one like this. Okay, so we have a quick way of creating this automatically for us. So if you go to your controller folder here, okay, you can see that at the beginning you should have home controller as a single file. Now we will automatically create the product controller by using the following command. So inside your terminal here, you can copy and paste this one down here. Okay, since I already have done this, so you don't need to worry about looking at because I have it already. But in your case, go ahead and type .NET ASP.NET Core Generators Controller. This is the option so that you can specify the name of your controller. And when we say action M, meaning we are going to look at the model. The model that they're going to look at is inside this folder and it's going to look at the products. Okay, so this is all together to say, okay, look at the model products and also look at the NSDB context so that they can look at the structure of the product table. Because in this case, the product's table name would be the product with S. Okay. Now, after the command has been issued, then you will expect to see that it's going to generate the product controller class like this. As you can see, whenever they want to perform the query, because of that command, it's look up and then give us the name of the table as the products as well with S. Okay, it has the index operations, details, create operation, delete as well. And alongside with the controller that is generated automatically for you, it's also go to the view folders and create another folder called products here with create, delete, detail, edit, and index. Okay, so that you have the support of CRUD right here. So that is how do you create the new products. So go ahead and add a couple more products in here. Okay. Now the next step that we want to do is after you already generate this, okay, in the step number 12, now we are going to have a ways to control our card controller. Now let's take a look at our card controller one more time. You can see that now I have a view with the title, a link, a graph over here, the date time pickers, and the table views over here. So there are many components that are the composition of this view. Okay, we are going to take a look at the first step. So step number 1, step number 13, we will create the card controller together. So in this case, go ahead and this time you cannot do auto generation for your code. You're gonna have to do it manually. So go to the controller folder here and then create the new name of your class called cardcontroller.cs. Okay, so you can right click, new file, and then name cardcontroller.cs. And now inside this controller, step by step, you're gonna need to import the above library into your class so that you can reference to many functions. Also, this controller will be kept inside this namespace test. Okay, so you can see that is the namespace here, and inside this namespace is going to be the structure of the class. So we start with public class. The name of the class will be the same as the name of the file, and this class is extend from this parent class, which is controller. Okay. Now, by including controller here, make sure that you have this import as well. Okay. That's step number 13. Now step number 14, you're going to need to declare a few variables to hold MSDB context in this class so that you can make use of the context. The contract will represent the database manager that allow you to make query, perform database operations. Okay, and this variable is belong to this class. Step number 14. Now in the next step, step number 15, since we already have declared this variable, but we're gonna need to have the actual DB context here. Now during the time that we register for inside startup here, during the time that we register for this, it's going to create the objects for this class MSDB context and put it somewhere in the memory. Okay, put it somewhere in the memory. Every time somebody make a request to card controller. Okay, so if this is the first time, the system will create the objects of card controller, and of course when it creates the object, it's going to call the constructor as well. Okay, and this objects is going to take in the objects that is available in the memory that has been registered at this step. Now once the object is available, by injecting this as the input parameter, okay, we call dependency injection for this process, we assign this reference that is available in the memory, okay, to our local reference, which is this one. So that now, from now on, inside the class structure, you can use underscore context, which is the representation of this object registration here. Okay. Now that's step number 15. I think I jumped one more. It's supposed to be 16. Let me go back and check this one. Okay. All right. So the next step. So after we already create this card controller here, the next step is, as you can see here, we need to also create the function index here. So this is like an action for MVC controller. It's going to be the same as without calling index. Okay, it's going to be the same thing. When the user issue index here, what happened? Well, it's actually go to the controller name card controller here, as you can see from the URL, and then look up the index function. Now you're gonna need to insert the new function implementation here. So you're gonna need to have up here, okay, data annotation as HTTP GET so that user can do it directly from the web browser with the URL. And the structure of the function will be public, async, and task of action result. The name of the action is of course going to be index. Okay. And this function can take two input parameter named D1 and D2 as well. As you can see here, we did not put D1 equal to something and D2 equal to something. Okay, so if you leave it blank like this, even if you make declaration right here, the value of D1 and D2 will be none. Okay, but we have the case that whenever user select these two parameters here, and then when we say select, it's going to call the functions index and then do something, and these two data will be passed as D1 and D2. We talk about that later. Okay, now let's go back to our implementation. So inside this function, okay, what you need is first, step number 18, we need to perform the query from our card information. Now let's take a look at what is inside the card folder here. The card table. If you look at the card here, we have card IDs and credit date, and if you browse the data, that is the card. Okay, so that means there are 5 customers who have already purchased their products and put it into the cart. So we have 5 different cards right now. Okay, so whenever you perform underscore context.card with S, okay, and then you can make what we call data projections. In this case, just like SQL, we say select, and we select all the column. Whenever you want to select all the column here, all the columns, we just say select methods and parentheses, put arrow function. X is the representation for each table, like this. Okay, so when we say X on the left hand side, that means each time they look up each object or rows in this table, X represent each row. And when we say the arrow function here and X, that means I want the whole structure of this table to become an object at the output. So it's going to take this row, copy this into set 1, take another row, okay, and copy into set 1 as well until it is done. So you can see that by the end of this operation, set 1 will contain, it is the list that contains 5 different objects. Each object will have the structure of card IDs and created date. Okay, so once you already have set 1 here, now what is the next step? Well, as I said, the user are allowed to specify the data range, the date that you need for query. Okay, so without d1 equal to something, d2 equal to something, you can see that the query will take d1 and d2 as null, like this. Okay, so if the query is like this, the card and then index and d1, it doesn't have d1 d2, so the d1 will be equal to null, which is nothing, and d2 will be equal to this as well. Okay, so in this case, after this is done, we know that we have 5 different objects in this list. We check again d1 and d2. If both of them are null, or either one of them are null here, okay, not null, both of them are not null, meaning user put something. So in this case, they are going to implement the URL calling that have something like card index, and then d1 equal to, for example, 04 29, date of 29 and 2019, and the second input parameter, which is d2, equal to 04, the date of 30s and 2019. So you can see that this data, when they call it from URL, this data will be assigned to d1, this data will be assigned to d2. So, but the data that we pass from the URL is going to be in the string format. We're going to need to convert it back into the proper type. So in this case, we use the function convert to date times, and then take d1 and d2 as the input. The output of this is in the forms of date time type, and I call it date 1 and date 2. Now once you have date 1 and date 2, now whenever you perform the query against the original query, we know this step will give us 5 different objects. Okay, so you can further change this operation output here. So we say, hey, set number 1, I want you to look up the objects that has, okay, when we say object mean it's represented by the X, that objects that created date should be greater than and equal to date number 1 and less than equal to date number 2. So in this case, we say the objects that had the created date should be within this range. Okay, so for example, if I select 28 to 29, so if you look at this, select the date from 28 to 29, so you can see that instead of 5 objects, after this operation, okay, after this filling operation here, the objects in set number 1 will become just the second object here because it is within this range. Okay, third one is okay because 28, 29, 29, so we're gonna have 4 different objects, okay, instead of 5 after this operation is done. Okay, unlike the first one, this one take all the rows, so it's become 5 different objects. This one look up only for the input d1 and d2 within this range, then you got 4 different objects. Now what is next? Well, after we have this one, okay, we're gonna need to support the output view. So if you go back to the output view here, you can see that I show only the card ID, the date, and the total of the card because we know that one single card like this one can contain more than one card item. So in this case, we have two card items. Okay, so we're gonna need to sum them up here. But how? Let's take a look at this. Whenever you want to change the structure of your selection here, we know that the original selection here, the structure of this is created ID and created date only. It doesn't have total. Okay, so we do what we call the selection here, and we can perform data projections. So the data projection will give us the following structure. And since we already create this card views in our step when we use data modeling, okay? So this one will contain the ID, the date, and the new fields that we want to create from here. So you can see that these two fields is already originally from the card ID and created date, which is from this one, card IDs and created date. And I rename it as ID and the date. Okay, now the next field is going to be total. You might wonder, how can we find the total from all the card items in this one? Now imagine that if you look at data model here, inside the card itself, it holds the list of card item, right? So that means you should be able to resource to or access from each card into card item, and then make the function called sum. Now when we say sum, it's going to loop through all the items. So now let's take a look at this. So imagine that now it's going to first look at this one, card number ID 1. So what it does is it's look at card ID number 1 first, and then look at card items. And they know that, oh, this card ID is the FK to another table, which is table card item. So they will look up each rows that have card ID equal to 1. So now you can see that there are two rows that match this condition. So what it does is it's going to take, let me trying to fit this together as a single line so you can see this result together. Okay, let me go up right here a bit. Okay, so when we make this query, what happened? First, as I said, it's go to the card table and take card ID, which is number 1. Now it try to match the second table here, and now we have two of this. So what it does is going to say, oh, okay, that P will represent our rows that match the card ID equal to 1. So when we say P, and then to the right hand side of the P, you can make the calculations. So you can access to this field and this field and multiply them together. As we can see, the left hand side of this is how we access or reference to each row. The right hand side is the table, is the output. Okay, the output. When we make summation, what it does is take 1 multiplied by 10 for the first time, and then take 2 multiplied by 20 for the second time, and then sum them up. After the sum here, okay, the output of 30 will be given to the total. Okay, after this is done, it go back to card item one more time, and then look up the second rows, and they know, okay, now I need to look at card ID number 2. So now they say, okay, we have the reference to card item. So go ahead and look up card item here, and then look at the match, and you can see that the only rows that it matched for card ID is this row, and then it's going to provide the P that represent this row, that P, and then multiply this and this together to give the output. Even you have the sum, because we only have one rows in this case, it's going to just sum one rows and give you the output, which is 2. Which is 80 in this case. Okay, so it's going to repeat the same process until you got the total. So that's why as the output. Okay, so this one is going to be used as the result. Okay, and now we're gonna look at the result together. So you can see that now whenever they return the view here, is return the index along with the result. Inside the view index here, if you go to view cart and then index here, you can see that at the very beginnings, we have to reference to enumerable of this cart view. Because when you return, look at this one more time. When you return this, the structure of the return is ID, date, and total that match this data structure. So at the beginning of your index view here, you need to also put this, and since it's going to be the collections of this object, so we put enumerable okay, before this guy. All right. Now if you look at this in the table, okay, in the table now we have the table tag, and that represents this table here, okay, that have card ID, date, and total. So same thing. So we have the header part and the row part here. So the header part we have card ID, date, and total, and this guy will be looped through the use of this, okay, syntax, laser syntax, add for each time you do the loop, okay. Add model is basically returned by this function. As you can see that this function, what it does is return object collection of type card views, okay. We have ID, date, and total. So that result can be referenced by using add model. And the reason you can use add model because we say, hey, at the beginning, that model will be conformed to this collection of this type. Okay. Now back here, each time when they perform the loop, we're gonna get the objects that have ID, date, and total. And in laser syntax here, you have to use add in front of this variable. Okay. Inside the syntax of the for loop command itself here, no need to put add in front of the variable name, but whenever you're trying to use that variable inside the tag itself as the value, you need to prefix them with add. Okay. Also, as you can see, I also have another column. Okay. When I click over here, you can note that over here that it shows the URL of the edit. This is going to be the ID1, ID2, 3s, and so on. It's going to call controller card, okay, followed by the action edit and pass 3 as the ID. Okay, we talk about that later. But this is how you hook up or connect, okay, the ID with this item ID. Okay, now that is how we represent this table. But the problem would be, how do we represent this graph? Okay, I think that's the deal. So in order to represent the graph, first we're gonna need to make sure that the function that return go back to the controller. You can see that we create the result right here. The result is returned with calling the view index. But we need to also let them pass the graph data as well. The graph, if you look at the graph one more time, the graph show, okay, data points up on x-axis is going to be the created date, and y-axis is basically the summation of all card item on the same date. Okay, so imagine over here, so you can see that now on the same date of 28, you have to sum 80s and 50 to become a total. So that graph represents each day ordering from customer. Okay, so to make this happen, well, there requires some steps, and I'm going to explain that in the next video tutorial. Thank you for watching.